Hey guys, today I'm going to talk about uh, assignment 8, problem 5. So this problem is a Castellino problem. The problem is asking you to find the deflection at point C in the direction of load NP, which is here. So as you can see the problem, uh, there are two forces that contributes to the deflection. The first of which is the distributed load in here, and the second one is the horizontal force in here. So um, to tackle this problem, we have to split this beam into two. So by splitting the beam, we can explicitly define where the distributed load is acting on that contribute to the deflection. So the first step is to split the beam into two. So from C to B, you can see that's the horizontal force acting on point C. So I'm just gonna write the moment equation right now for the beam from C to B. So the moment is equal to P, the force, times r sine theta. R sine theta is the moment arm that changes from point to point along the curved beam from C to B. And the derivative of the moment with respect to P is r sine theta. Similarly, for beam A to B, we have moment equal to the horizontal force times the radius of the beam. Since at point B, the moment from the horizontal force is equal to P times R. And that's another contributor to the moment, which is the distributed load from the top of the beam A to B, which is the distributed load times the length x, and x is defined from B progressing leftward to A. So this is x. So Wx is the force, and Wx divided by 2, sorry, Wx times x divided by 2. X divided by 2 is the moment arm. So this is the force, and this is the moment arm from B to A. So the derivative of the moment with respect to B similarly is equal to R. So the next step is to write the deflection equation. The deflection equation is for the part C to B is equal to pi over 2, 0 to pi over 2, since this angle is 90 degrees, which is pi over 2. So pi over 2 moment divided by EI times the derivative of moment with respect to P times R times d theta plus integration from 0 to L. So this is the portion of A to B. So 0 to L is simply the length from 0 to L. And then moment over EI times this, same as the section from C to B. And then since we already acquire the moment, the equation for moment and the derivative of moment, so for segment C to B, we just have to replace this, substitute it in here, and substitute here. For A to B, we just have to substitute this term to here, and substitute this term to here. And then expand and simplify, you will get something like this. Okay, that's 2. And then when you solve the integration, you should get something like this. So that's the total deflection of the beam at point C. So that would be the horizontal deflection from point C. So thanks for watching, and I will see you in the next video. Thank you.